Welcome everybody. My name is Eduardo Lima. I work for Igalia. It's a consultancy from North Spain, and I'm very glad that I was invited to come here and talk to you about the wonderful things that we do in GNOME related to JavaScript. Yeah, it's a bit about me. I was a web developer a few years ago, then I became a GNOME developer, but I kept doing things related to JavaScript and on the web and in the server side. I have involvement in other projects as well. And as a disclaimer, I must say that I'm a GNOME Shell, neither GW introspection, GES core hacker myself. I'm just a messenger. I want to bring a message from the GNOME community to all of you and try to present you the technologies we have been working on for the GNOME 3. With two purposes. One of them is to communicate the great technologies that we have been working on very hard in the last 3 years, and second, try to raise interest in the wide JavaScript community about GNOME and developing applications using our wonderful stack of libraries. Let's start by asking the question, what is GNOME? Okay, GNOME is a group of people. It's a truly community-driven project. It has 11 years already, almost. Yeah, it's also a full-featured desktop environment. I'm going to ask you how many of you have tried GNOME or have seen it. Oh, cool. So it will be easy. Yeah, so you can see in this slide, that's the GNOME 2 in those, and this GNOME 3. Maybe you can see a clear difference. Okay, GNOME is also a collection of libraries and programs. You're not supposed to read all of that, and all of them are free software. There's a bunch of programs and libraries that has more than 10 years of evolution. And they have been used in production for a lot of time already. Yeah, in April this year, GNOME 3 was released. It was a very important milestone for us. There was a lot of people working for a lot of time on this. And the GNOME 3 included a major breakthrough in several points. For example, in design, we just revamped everything. We created a new user experience. We now use the new hardware capabilities that we have in modern computers. And we really did a lot of work cleaning up the stack. There was a lot of, the stack was very, was very full of things that we really didn't need, or we could really remove from the stack and make GNOME simpler. And yeah, also we introduced the Genome Shell as a default user experience in GNOME for this version. The Genome Shell, maybe some of you have seen it already, is just a full desktop experience integrating compositing. Okay, loader, or is it fine? Okay. Okay. Yeah, it's an application launching, switching. It allows multiple desktops and much more. In fact, 2 years ago, I was attending JSConf, and I had a very early version of the GNOME Shell running in my laptop, and it really raised a lot of interest when I was showing it to the people informally. And I realized that there was a miscommunication from the GNOME community to what we were doing. Yeah, you read there that this JavaScript is powering the GNOME Shell. It's the glue that we are using to access the low-level C libraries of GNOME. Yeah, you can see it's almost 30K lines of JavaScript against also 40K of C. Yeah, I realized that we need to communicate GNOME in other forums also, because it's very attractive platform right now for JavaScript developers after the technologies I'm going to be presenting today. So this is more or less the GNOME Shell stack. We use OpenGL in the back. We have this great technology, Clutter, and we have the old meta CD wrapped by Matter. We have the Shell toolkit. We have also CSS for the theming. We have this GeoObject introspection layer that we're going to be explaining, and we have the JavaScript engine. And on top of it is GNOME Shell. Maybe I can show you very quickly GNOME Shell, or maybe it's not needed. Raise your hand if you haven't seen GNOME Shell running before. Only you? Or maybe later. I can show you. So we're going to be focusing on these two technologies that really are the technologies that allow us to have access to the core libraries using JavaScript. So let's start with introspection. What is GNOME GeoObject introspection? Well, it's a set of tools that we have to extract the metadata of C libraries. We extract the API description in a format that is very easy to use in a runtime, not in the compile time. So we extract the API contract of a library, and we put it in a very well-known location on the hard drive for other programs to access it. Yeah, we need to realize that it's not as fully automatic, because we need to annotate the APIs, which we're going to explain what is it. It's a very simple process. And also, we should design the C APIs in a way that they are introspection friendly, meaning that there's no weird C tricks on it that make it very alien for other languages to bind. So the goals of this technology are basically to enable us to use the C libraries in bindable languages like JavaScript, Lua, Perl, Python, etc. And there's also other uses like API verification, documentation, and yeah, this is the most important thing, I think, the second one, which is shared binding infrastructure. Nowadays, if you have a library and you want to make it introspectable, if you want to make it accessible in a scriptable language, you need to write a binding. And it's not the same for every library that you write and want to use. You need to create the bindings also. And it's a lot of work, and it's duplicated work, because the bindings that you use for accessing the C library in Python, it's almost the same code that you need for JavaScript or for other languages. And what we're trying to achieve with the other introspection is to concentrate all that effort in just one library and make the binding work very simple. Oops, sorry about this. I will mention that this technology was initially created by a startup called Little, that they wanted to create a new user experience for the vision of the device. And they hired some of the very good GNOME hackers from the GNOME community, and they started creating this technology. And as a result, this technology was contributed back to GNOME, and we were able to use them for this new experience. Okay, this is kind of big. I will try to wait. Doesn't matter. Okay, sorry about that. Well, this is basically a big picture of what's going on here. The only bit missing is the label that says runtime in the other side. So this is compile time, this is runtime. This is our library. During build time, we have a normal compilation through GCC. We also have this process, which is this script called jsconf creates an XML file. It's an XML representation of the library API, and then we have a process of compiling this XML to a binary file, and then at the end we have there's two inputs: a typelib file, which is binary file, and the shared object, the normal shared object of the library. And during runtime, we have grepository, which is we're gonna see it after, but it's a library that allows us during runtime to access the symbols and the API description. And we also have this library called libffi, which stands for foreign function interface. It's something very low level that we really don't want to be discussing much, but it's the one that allows us to access a shared object of a library during runtime without knowing the headers, basically. So we can know, having some information about the API, having the metadata, we can actually use the library without having compiler programs with the symbols of the library. GJS is the JavaScript engine that we created. It's a wrapper to the SpiderMonkey engine, and it provides the access to the G repository. So GJS is the one that combines the metadata that we obtain from the introspection process and the shared object that we obtain during compilation, will allow us to use to make the automatic reflection during runtime, which is our purpose. And SpiderMonkey, well, is the Mozilla engine we all know. So this is the same thing, but for C and the JavaScript core engine. It's exactly the same, but I'm sorry about this problem. So what I wanted to point out with this chart was that only changing the engine and the wrapper, we got the same thing. So the work that we need to do to use this technology is very limited to what specific JavaScript engine we plan to use. And yeah, this is what I explained before. The JIR file is an XML description of the library. This is an example. Maybe I can scroll a bit here. It's just an XML file with description of all symbols, library functions, arguments, classes, etc. In the case of classes, I'm talking about the object, which is the object system of glib, the library where GNOME that GNOME uses to power oriented programming support in GNOME. So a typelib is just a binary representation of this GIR file for faster access. We don't really want at runtime to be parsing XMLs. We have a very optimized representation of it, and we use it during runtime. And this is the only purpose of the typelib file. So the GIR files and the typelib files are stored in a very well-defined locations so that the GJS engine could find them at runtime and load it dynamically when they are needed. The GIR repository, well, it's an API for retrieving library information from the typelib during runtime. GJS extracts the symbols and use those symbols to access this thing, which it's so low level that we really don't want to deal with it. It's like science fiction right now in this context. But basically allows GJS to access the introspection information from one side and be able to actually access the library runtime using this library, which is a very old library. It's part of Linux from a long time. So annotations, they go inline the code, normally in the form of in the C files. they complement the API with information that otherwise wouldn't be possible to obtain only with the syntax. So it's semantic information that is not evident in the source code, and only the programmer of the library have access. For example, in the case of when you created a block, you allocate a block of memory, and you want to use it and then free it, but sometimes it's the responsibility of the user of the library to free it, and sometimes it's the library itself. But in the source code, there's no information about this explicitly, and only the programmer of the library can know about that. So this is one of the cases where you have to annotate the code. For example, this is an annotation. It's just a common block on top of the symbol. In this case, we're annotating a function. And the annotation part is marked between parentheses. For example, in the case of file name, data, they allow none, means that you can pass null. If you don't put allow none, you cannot pass null when you are in the scriptable language. And also we have something interesting here. Oh, sorry. In the case of data, we annotate there that it's an array, and we specify what other argument is the size of this array. So this information could not be obtained just from analyzing the syntax of the library. So we need to annotate that to allow the bindable language to make the magic and to make everything work as the library designer expects. Yeah, this is another example. In this case, we are annotating the return value. This is a glist, which is a linked list in glib, but it doesn't store any information about the type. It's just a pointer containing this glist. So we need to annotate that. That's what the element type annotation is for. And in this case, we annotate, we say that the element type of this glist is a clutter actor. It's just another symbol of maybe another library, which is not the case, but it could be. Yeah. So up to here, we discussed about the object introspection. Is kind of the foundation to be able to allow scriptable languages to access the power of the library, the C libraries that we have behind. And now we're going to talk about the engines and how they combine with this object introspection thing. We have two engines currently in the GNOME technologies, and one is GJS and the other one is Seed. GJS is wrapping the Mozilla SpiderMonkey, as we saw before, while Seed is JavaScript core. SpiderMonkey supports some of the Harmony yes things. This is actually a problem right now because a lot of code, the GNOME Shell code is written using let and const everywhere, taking advantage of the features that are available in the SpiderMonkey engine already. But the Seed project doesn't, the JavaScript core engine still doesn't support those. So we right now have a problem on compatibility. We cannot run GNOME Shell code in Seed, only in GJS. Yeah, GJS is more mature right now. It powers GNOME Shell at the moment. It's in production on millions of desktops right now. And they have some other minor differences, but both have a fairly good support for GI. And we have this thing that is very recent and it's very cool. There's a guy called Tim Castle working in this Node Gear, which is GI support for Node. And it's in an early stage of development. And that's his reason for writing this instead of using the others. And I kind of agree with what he says, but my advice to him would be, first, ask the GNOME developers, go to the community, try to talk with us, and try to, be advised about how to do this well, because we have a lot of experience already. doing bindings for these engines. And we also, he has some ideas like implementing the, of course, it's meant to be run in Node as a Node extension. And it will be the Node way of doing things. And we have some kind of a bit different vision of, for some of the APIs that don't really match exactly. And my advice to this guy, I haven't talked to him already. I discovered this project very recently and included here. But I would say go and talk to the GNOME community while you write this. And we are glad that you're writing this, actually. So how is writing JavaScript for GNOME? I'm going to show you the demos first to try to get you excited about it, and then I will show you how could you start doing. So let me see. I was planning to code the demo on the fly, but maybe, oops, what's that? I did something. It's not supposed to be there. Wait. Yeah. Okay. Yeah, we can try to to code a demo on the fly. Maybe I can. Oops. Okay, I have Emacs here. So I have to code there. We're gonna first import everything we need. For example, let's do a very basic GTK application with a button and with a greeting message. So let's import GTK. We're going to explain everything after the demo. So right now, maybe you wonder about some syntaxes there, but just don't worry. Yeah, we have GTK, we're going to instantiate a window. GTK, the window, say new, window. GTK, window, type, top level. So we have the window. This is a constructor. GTK window is a constructor, and we are instantiating it. We have a property name type. It's a property of a GTK window, and we pass all the properties in the constructor using an object. And then we say show all. And then we need a main loop, because JLib is based on main loop. And there's a wrapper in GTK for a standard JLib main loop, so we can just do this. OK, let's save it and try to run it. Let's get the console here. Oh, the console is small. I hope you can see. Maybe I can. Oops. Oops. Oh, sorry, I make half.
Uppercase window.
Oh, yeah. Sorry. This should be uppercase. Oh, yeah, we need this. You need to initialize everything. This is part of GTK thing. So we have a GTK window running. But this is not all. We close the window. As you can see, the program keeps running. That's not nice. So we're going to connect to the destroy signal of this window to kill the event loop. And we're going to do it this way. Win.connect, destroy. We're going to be putting a function here. Okay. And we can say GTK main quit. Nice. So now we run it. Oops. Why here? Come here. Now when we close the window, we close also the program. And now let's add some button here. Button is GTK button. We need new because it's a constructor. And we can pass label to it. Hello JSConf. Or some kind of, yeah, I think it's right. Oops, no. Okay, I think it's fine now. And we're gonna add the button to the window. Yeah. Let's try it. Okay, now the window is very small because the button is small. Let's make it big. We have a GTK button here, which does nothing. And now if we connect to the BTN, the signal clicked, we can print some message to the user, like hello back, for example. And okay, that's very simple. So it's a very stupid demo to show the most basic things that we can do. And I'm gonna show another demo which is more complex. I have it already written. I'm gonna just run it for you and hope you like it. It's here, it's GAS demo 1, I think, yeah. This is a webcam. This is running GStreamer and Clutter. It's hardware accelerated, of course, because of its Clutter. And it's using GStreamer for capturing. It looks kind of crappy because I just put a cam source and a sync in the texture, but I didn't put the other elements of the pipeline that, for example, a color space. We need to get this right, but I just wanted to show some cool things to you. But the thing is that we're going to check the code, and we're going to see it's 40 lines of code only in JavaScript. Let's wait. It's demo 1, yeah. So it's kind of the same. We have GStreamer, which is this line, Clutter. We have Clutter GStreamer, and we have a main loop. We call GStinit to initialize GStreamer. We initialize Clutter. We create a black color for the background. We create a stage with the size. This is normal construction. We set the color of the stage. We connect to the destroy signal of the stage to close the program. We create a Clutter texture. We add it to the stage. And we set the size of the texture here. Then we create a JStreamer pipeline. We create a plugin for the cam, the webcam capturing. We add it to the pipeline. We create a sync element. We create a video sync element, and this is where the clutter JStreamer thing goes mixed. And we add it to the pipeline, and then we link the source, which is the webcam source, with the sync, which is a clutter texture. So at this point, we created both the pipeline, we linked it, and this is for the rotation effect. We created the vertex. We specify the center of the rotation. All those are properties of normal G objects that we have. We normally use this in C, but here, as you can see, the syntax is very similar. And now we do, we have a main loop with a timeout of 25 seconds. And we just modify the angle, the X angle and the Z angle. At the end, we just show all the elements of the stage. We set the pipeline to playing, and we run the main loop. It's 52, sorry. So that's it. We can do a fancy JStreamer clutter thing only with 52 lines of JavaScript code. And there's so much more behind to be used. This is only one example of two very popular libraries that we have in the GNOME stack. But there are a lot more cool things. So let's continue. Yeah, this is a special, let's say, a native JavaScript module that is built inside JES, which is a wrapper to the main loop for convenience use. Here we created a main loop, a glib main loop, using a main as ID. So we can have several main loops running, and we can refer to them using this ID. So it's something that is very specific to GIS. They implemented that way for convenience, basically, but we could have used a normal glib main loop here, and it would work the same. Okay, I think we could continue with this. Maybe I have time for another cool demo, which involves the web also. And I think it's also kind of cool. Wait. We have to go. Yes. Let me check something. Okay. Okay. GIS. We're going to run the demo. Okay. Now we're going to open a browser. We already have one. Another Chromium instance. Oops. Okay. Nina, it's localhost. Okay. We get this image. Oops. This is a demo of technology. It's a C library that is introspected and do kind of a mix of Node.js and Socket.io. So we're going to show also, let's open another browser, let's say Epiphany, which is the, oops, Epiphany doesn't want to run here. I don't know why. Let's open Ice Whistle, which is Firefox in Debian. And let's do this, bring it here somewhere, move it like this, and we can. We also work in Opera, actually. So let's put Opera in the game. Yeah, Opera is here. Wait, let's bring it here. I don't have room for it, but maybe. Oh, wait. Oh, yeah. Sorry about that. Okay. So now we have. This is using WebSocket, fallback to long polling. It's full 100% JavaScript, server side and browser side, of course. And yeah, it's kind of the cool things we can do now that we have a lot of libraries to access, a lot of hardcore things in the server side to use out of the box just by using this technology. Okay, enough with the demos. I hope you enjoyed them. Let's see what is this about. Okay. So, importing modules is a bit different of what the Common JS project has already spread around all the JavaScript developers. There's no required thing. The imports operation is an assignment, not a function call. This is actually not nice because you cannot do a lot of things that you can do with a function call, like for example, implemented the asynchronous loading using the required function as an object for all things. And we have an importing, I think it's very limited. We also, this is the most serious problem we have, the full modules global scope is important. So you know, if you use CommonJS or Node.js, you have the exports object and you add API to it, and that's the only object that gets exported. Well, here, everything goes exported. If you have private symbols, they will be exported as well. So this variable inside your module will be exported completely. And I think that's a problem, and we need to improve that. There's also a search path, similar to required paths, and there's only synchronous, of course, it's an assignment. This is an example of importing a normal JavaScript module. You specify the path to the module using dots instead of slashes. These are the 3 examples. Here we use const, which only works in GIS. And this is the nice way to do it because module importation should be immutable, and we can get that with const. This is importing a GI module, which is an introspective library that we have in the repository, in the G repository. We use the GI member of imports, which is we can say it's a keyword, right? It's part of, it's immutable. Using GI, we have implicit access to the G repository using the namespace. When you compile your library with introspection support, you have to specify a namespace for your library. And in this case, glib is glib, like this. GTK is GTK, like that. It's up to the library developer to create the namespace to be used for the G repository. Yeah. You wanted to ask us?
Yes, it's not really about GTK minus.
Yeah, it's a weird construct, but it works that way. In the newer versions of DAS, I think this you can put equal. You can assign to imports GI GTK. You assign a 3.0, but it does not work in this version of GS that I have running.
No, what I was saying is a minus sign can't be
Yeah, but that's not that works that way. Hmm?
So for JavaScript, it should say
Yeah, I agree.
it was minus 3.0. So that's kind of weird for us.
Yeah, for me too.
So why does it? I mean, okay, so what are the rules there?
Hmm?
What are your rules for that?
I think it was it's already deprecated way of doing it. I'm not aware of the decisions that the left to that, but this is the new way of doing it. But I cannot tell you right now why it was like that. I could try to find it and tell you after if you want. It's like, I think it would be like a symbol as a whole, everything. Yeah. So there's also the native modules that I was talking before, like a main loop. You have dbus, wrapper to make it more convenient to use on JavaScript and the JS. You have a lang with some language utilities and the signals module also. Yeah. This will be imported in native JS mode. They are always accessible from the root importer. So, using the GI APIs, how to map the symbols that we have and we know in the C library that are very well documented to the new bindable language. We have a set of well-defined rules, and they are not actually in 100% of the cases well-defined, but there's with practice and while the documentation for binding language is not in place, we can kind of learn how to map the symbols to the C symbols to JavaScript in this case, and it will always work for most of the cases using some simple rules. For example, functions. Functions. If you have a normal function, you will use the namespace dot the name of the function like this. For example, gtimeout add becomes glib timeout add. It's kind of normal. You only need to identify what is the namespace of that library. In this case, it's G. It's the C namespace of in glib, and you replace that with the namespace in the G repository, which is glib, and you have glib timeout. It's kind of a trick, a rule to guess it. Yeah, in the case of GObject methods, they are used like this. You have to map the namespace, the class, and then the method. So let's say we have GTK button new with label. It becomes GTK dot button using a camel, and then new with label. So it's kind of a very simple rule. And in the case of enums, it's kind of simple also. You use the namespace, then the middle part of the symbol, and then the last part in uppercase. The properties of objects are in C and in GObject in this case, we can use dash for the properties because they are strings, and we need to replace them for underscore to be able to use them as normal object members in JavaScript. The signals, as we saw in the demo, you use the connect thing, and in C it's different. They have this signal object with members where the signal names are the members of that object, and all of them have a connect method. You pass the callback, and that's it. And I forgot about I forgot about constructor. What we saw in the demo. For constructing a GObject, you use new, the namespace, the class name in camel case, and then you pass an object as the only argument, an object with all the properties that you want to define to pass the constructor. Okay, so what about documentation? Right now, documentation is poor, actually, for the binding languages. There's no official documentation. We have unofficial documentation there, and it's kind of nice. But let's remember that also we could have some lags in the actual C library documentation. So it's like a complex thing to do, and this is very recent. We have been very busy bringing this technology up today, that of course we are lacking a bit for the developer story for bindable languages. So we need to work on that. And in fact, it's a hot topic right now. Last month in the Desktop Summit, we have a GI Hackfest, and the focus of the Hackfest was basically documentation for binding language, Python, JavaScript. So we are really concerned about this, and we want to fix it as soon as possible. Development tools, we don't have them yet. It's too early for us. We don't know we have a lot of discussions inside the community yet, still, whether we're going to use Python, JavaScript, JS, we are not sure about the developer story yet. We haven't figured out all the details. But I think there's a lot of interest in having very good development tools. And if we want this to succeed and attract developers' attention, we'll need to fix this also. Okay, this is very important. How to synchronize our community with the rest of the world, basically. This is a very delicate issue because there are some people in favor of it. There's other people that are not very interested. Try to gather some opinions from the core developers of these technologies. And well, the basic idea or the basic message will be that it could make sense for some of the common JS libraries, but maybe not for all of them. Because, for example, we have the GIO library, which is part of glib, and it's the library we use for input-output. And we have specific ways to do asynchronous operations. We have specific ways of doing things that integrate well with the rest of the GNOME libraries. And we really don't want to mix code from common JS APIs, for example, for the HTTP, maybe, I don't know. We really want to use the GIO way because the Python developers will use that, and the Lua developers, the Vala developers will also use that, and we really want to make a consistent message to the developers on how the APIs should be used in bindable languages. So for some APIs, it could make sense to synchronize with them. For example, I really want to push for the modules because it's a basic thing, and I think we could improve a lot the situation if we have some module importing using modules 1.1 at least. There's a lot of, well, we need to discuss a lot and try to bridge the two communities and discuss what makes sense, what makes not sense. That's the Node.js project, which will, in a way, bridge the two APIs, because we are going to be using GNOME libraries in Node context, and this guy is really I was reading what he wrote about what style to use, and he really wants to implement what makes sense in the common JS context. So he wants to adapt even the syntax to common JS, to what is familiar to Node, at least. And this GJS, common JS, is a very new project I just created as an experiment. It's a wrapper to GJS to provide common JS APIs. My purpose with this is not to create another wrapper on top of GJS to have common JS, but trying to convince people and try to move, at least create some debate. And maybe if the experiment is a success, meaning that some people do use this wrapper instead of the actual GJS, maybe we can convince people that to merge these APIs, or the APIs that make sense, inside GJS itself. So it's not the way to go in the long term. I want to push this. It's just for an experiment, and this is very new. I started writing it like a month ago, and it does modules 1.1 and promises the conditionally compliant. At the moment, it's there, and you can check it out. It's kind of very super pre-alpha thing, but anyway. So what current issues we have? We have a lot of challenges, like, for example, the documentation thing I was talking about, and we still don't have complete support in all the GNOME libraries. Maybe in the core libraries, yes, but we have a lot of other libraries that still need to be introspected. Oh, sorry. And we need to complete the support in JS, official documentation, solve the differences between JS and SID, and try to align with those. Some final thoughts: we have a very nice stack. It's a very nice combination of low level and high level. We are basing our code in a platform that has a lot of years of evolution and will give us robustness and confidence. And it's very convenient for fast prototyping. I think I use it a lot. Something quick in JavaScript to try some native code API. And of course, it brings JavaScript to the desktop. This is an awesome stack. We have the libraries, the GNOME libraries. This is only the core GNOME libraries and GNOME 3 stack. We have introspection, and we could have a lot of engines, and then our problems running on top. And I think it's very awesome and very interesting platform to develop upon. And that's it. Sorry for taking more time.